Hi guys, I hope everybody's okay. So we're officially going to start with Build with AI. Please just note that everything here is definitely recorded. So I'm guessing you're watching this on YouTube if you're not here with us, but catch us on our social media. That is Instagram, Twitter, and WhatsApp. So if you're not on the WhatsApp line, just let us know. We'll put the link in the chats and LinkedIn. So anytime you come to our videos or our in-person events, please do tag us on LinkedIn. We know LinkedIn is always such a nice place to be tagged in. So we are about to start. This is GDG Soweto. We're so excited to have you here. Right now, we are doing boot camps. If it is your first time in this boot camp, we have boot camps for about 8 weeks now. We were on a break last week to get people to catch up, but we have boot camps preparing us for DevFest, which is so exciting. We're very excited for DevFest. Make sure to join us for DevFest and be on our socials so that you can know if there's any prizes to win or anything else that we can do to make DevFest a bit more exciting for you. So today we are going to be doing Build with AI, Introduction to AI and Machine Learning on Google Cloud with our very own Alex. Um, we Alex did speak for us, I think last week, but we're very excited to bring him in here, and he did such an amazing job because he does a very walk through everything, and you're more than welcome to ask questions in the chats, which I'm sure he'll answer. But if he doesn't answer, we've got about 10 minutes at the end of the presentation for him to answer. Hi, Alex, are you ready?
Yes, I am.
Okay, let's take it away, Alex. Thank you.
Thank you very much, Gigi, for the introductions as always. Thank you very much, guys, for joining us for another refreshing week with the bootcamp. So, today I'll be taking you guys through the introduction of ML and AI. Right, and today it's going to be a little bit interesting, Yana. So, I'm thinking of doing a build a bear version of this slide. So I would like some contributions. I want to see that if my information is still up to date as to how I know it. Anything that you guys have picked up on the side that you think must be cool, please drop it in the chat, drop it in the WhatsApp group, and then no, guys, let's get started. Right. So Google, you see, Google is a problem, guys. They create so many beautiful things that we don't really appreciate from the face value. Things like your Google search, pretty sure you use it every day. Android, use it every day. But in you knowing that these tools are from Google, there's something that was sparked up. That was, I would say, it's the home of not only machine learning, but also AI as we know it today. Google have been in the pursuits of trying to capture this machine learning vibe back. If I'm not mistaken, 2016, and that's when they were coming heavy with their TensorFlow libraries. They were doing recommendation engines. That's the forefront of what machine learning into the spaces that it's in. And if you were to ask me what is recommendation engines or systems, if you've ever watched Netflix, you've ever watched your Showmax, you've ever been suggested something that you think that you might need, that was machine learning running in the background, running on your data that you have with Google. Let's say I am an avid anime. So when I'm in my YouTube, I'm just randomly searching through the Google's tooling and ecosystem. I would see some recommendations that show up, and I'd be like, I have a feeling of I know where this is coming from or where it could be pointing to. I know that there is machine learning happening in the background. And today, it's basically going to be a build a bear version of how did we get to these systems? How are they different from the current systems that we usually interface with? And as you would see with the first slide, I'm going to be breaking down what machine learning is because everybody is so hyped up on AI. And I'm like, it's machine learning, just wrapped up with a beautiful t shirt, eh? But in you looking at this image that you see, that's right here in the middle, machine learning is a subset of AI. just like deep learning is a subset of machine learning. So I'm pretty sure you guys have seen some tutorials of robots moving around and stuff. That's deep learning. It uses something called reinforcement learning. So it is able to pick up data from its outside world before it makes a decision. And then with that decision, it enforces an action upon that decision that it has finally made up. That is going to be falling underneath your unsupervised learning techniques that you have underneath machine learning. Your recommendation systems, those can be either from a semi-supervised learning or a supervised learning approach, meaning that they have the full data of the person that they have in the system and they know what kind of products they'll be recommending to you. That will be supervised because they know who you are, they have your data, they know you're like watching Mama Popeyes after this time and stuff, so they know like, okay, this is the type of person that we can send this type of adverts to so that we can try and generate revenue from them. So if you know for a fact that you're using Google AdSense, and with your AdSense you're able to set up your profile and you know that, okay, as long as if I'm within the network, I'm paying for my subscription, I want my type of products to be recommended to a certain particular group of people. So if it's Popeyes, I know my mother doesn't watch that, my sister is not a fan of that. In them getting those ads showing up in their mobile view, web view, it's going to be a waste because you won't be getting the target market or the target audience that you were aiming for initially. And then someone's going to be like, but yo, but Alex, that information looks cool. The new thing now in space is AI. How do I dive into that? And I'm like, it's very simple. Anything that comes within the space from AI, ML, deep learning, it all relies on data. Everything is data. Without data, you might as well walking around without a walking stick and we're assuming that you're blind. You're just building a system that's got no data. I mean, yes, there are systems that have been built in such a way that they do eventually, as time go by, generate the data required to move forward. So I'm pretty sure you guys have seen the way that certain models have been created in the space with reinforcement human feedback, meaning that even though it is generating this information, so you're busy there out here Gemini, sending some requests in the terminal and stuff, and then it's gonna prompt and ask some questions to get a better feedback. Meaning that, okay, if I'm working on a code base, I would like to try 1, 2, and 3. I would like to try the strategy or a different database. It can use human feedback, or human loop, as they would call it in the AI space, a human loop to make sure that it doesn't hallucinate and do its own thing. You always curate it in such a way that it's within the context of what you're trying to build and it's within the guardrails of what you're looking for. So now we're gonna move over, and as you would see, this was taken from Google's official website. AI or artificial intelligence is a discipline. I will be sharing those links so you guys can have further readings. Make sure you're also well informed and you know what's going on. In them saying it's a discipline, it's basically a way of thinking. It's not about only the tooling, as you would see as I go through. Because today we're doing a build a bear version. We want to see how far, how wide can we actually use AI and what do we understand of it. The most important tool that made me realize there's more to the world than just Python was TensorFlow. TensorFlow was the OG machine learning framework created by Google. It's been used, if not everywhere, anywhere inside of Google. They are machine learning heavy in the way that they approach operations. They want to make sure that the information that they give it, the data, is always aligned. It's always in such a way that when it's been given to a model, whether it's self-hosted, whether it is Google APIs, the information is always consistent. I'm going to also share a wonderful conversation that was, or a presentation that was given by Casey Kazacroft. She is a former decision scientist from Google, and the way that she breaks down machine learning, it's baby steps. But with this current page that you're looking at, there is two ways that you can do machine learning and AI. One, you can do it by hand, as you see on your left hand side. Use your own data to train your models. And the minute you see TensorFlow, it means you are manually building out applications, machine learning applications, to serve the requirements that you need in order for you to fulfill a business requirement. Meaning that, hey, I'm seeing that the voice LLMs are not up to the par that I'm looking for. I think I can build a better one. Not a problem. You hop into TensorFlow or into an IDE to be more exact. You download your packages for Python or Jupyter Notebook, and then you load TensorFlow. And then knowing how you want your systems to be working, hoping that you have a PRD, a product requirement document, you can actually start building out this voice LLM from scratch. And you know for a fact what kind of data is going to be going in. Is it only going to be for English speaking? You can tailor make the solutions that you bring to GCP. But if you know for a fact that Alex, I would love to get into that, but I'm still trying to figure it out. Still my first rodeo. I'm like, not a problem. The nice thing about GCP, it is family friendly. Yeah? 5 years and upwards, anyone can use it as long as if you are ready to dive deep and actually be an engineer to not only make these things work, but to make them work efficiently. GCP is always ready for you. And as you would see, moving away from TensorFlow, you would see there's a cloud machine learning engine. Meaning that's a general machine learning engine on there. So if you're like, hey, yeah, I have this type of data, what can I do with it? And you're an e-commerce site, and you'll be like, okay, I want you to learn from this data. And then eventually send ads to people who are searching or have bought similar products in the past. So these are called pre-trained models already on site inside of GCP. And as you would see, there's other offerings. Cloud Vision. If you out here you want to see how far someone is away from you, is that a cat or a dog? This is the one you'll be using. Speech. Instead of you building that voice LLM from scratch, you can use GCP pre-trained ready ones, and then you know for a fact, okay, sharp. My app is in English, but I would like for it to translate for isiZulu or Spedi. If they have those uh, localization settings and APIs, you can enable them and then make sure that every time when it serves to a particular region, a particular user group, those models kick in and then they can interface with them with their own home language. As you would see, Cloud Jobs API, first time seeing it. The one I'm pretty sure everybody is familiar with, Cloud Translation API. And to show how powerful this thing is, back in when I was still trying to figure out this IT thing, I did web development with Google. The only catch was that the program only ran in Spanish. So I had to convert each and every single website and assessments and tests from Spanish to English and then complete them and then eventually get those certifications. And I'm like, okay, that was like the day when I was like, no, machine learning AI is actually a real thing because if I can get the same information, I can't speak one lick of Spanish, but I'm pretty sure that the information, if it's converted to English, I can still respond and give a thorough feedback. It should be enough for me to get the certifications. So I managed to get those certifications, and I'm like, machine learning, number one, you must trust. And then you see Cloud Natural Language API. So instead of you just speaking, now you have one that speaks with language, meaning, okay, am I speaking English? Is it Afrikaans? And I'm pretty sure with the translation app from Google, you can have it speak back to you. So if you know that, hey, I'd like to go to Cape Town, you can go down to where it's translating to whatever language and hit that play button and hear if it's actually one to one with how you'd hear it in your own language that you would like to hear from. Video intelligence. People have seen VO, they've seen Flow. Super cool. And I'm like, yeah, guys, there's these APIs on GCP. You can build this thing yourself. You're gonna pay how much? Yeah, no. Here's the thing: if someone is offering you something at a certain price, that's the most expensive approach. The cheapest approach is to build it yourself and host it yourself. And if that is expensive, and then you fall back to the option one. And I'm like, that's how you eventually end up learning more about the system. You end up knowing more about the actual technologies and tools that should be used. Remember, you're not only going to be using it here in this program, expecting that once you graduate, once you grasp this knowledge and all this information, you're able to deliver business value wherever you are, whether you're tinkering in your own house, whether you're still in school, whether you're working. We want you to be able to be, hey guys, you remember a few months ago we were in this program? Oh yeah, oh, learned so much. We tried to do 1, 2, and 3. This is what we have. We want to see those LinkedIn posts to show that the things that we're doing is actually meaningful and it's actually progressing not only the IT space but the community as a whole. And then now I'm just gonna give you a. This was like a demo that I found through my Google search, and I'm like, this is a very clean architecture, as you would see. The new tool, I presented this, I think, a month or two back, where we were talking about conversational agents. We were using the Vertex AI Workbench. So all those tools that you saw in the previous slide, you would either enable them one by one, or you can have a workbench where you can have everything pre-baked inside. You understand? And me, I'm sitting here and I'm like, okay, this is a very clean, very clean architecture. Because one, it shows you how you would usually be deploying this type of solutions to production. Because people think it's just AI, and then bah, it's a URL. And it's like, there's steps to these things. There is levels to these things. And you'll be like, okay, what levels? One, think of an AI model like a binary, like an EXE, like an APK. Something that you have to press on and it must run. Not an issue. Where would that be stored? How would that be stored? And then now you start seeing, well, can't be just deploying a model. It's deeper than that. It's more than just writing code and hoping that it works. The first place that we can use it in is cloud storage. So cloud storage can have different types of storages. Something like your structured storage, things like your SQL and stuff. And then there is your blob being your binary, things that aren't easily read. Like for instance, PDF. A PDF, Alex. A PDF is just a PDF. It's like a Word document. And I'm like, 50-50. Because one, if you were to open the OG binary of a PDF, you'll see it's a bunch of gibberish. And why? Because that's encoding. Because documents, depending on how they are structured, and I'm pretty sure most of them, they must have an encoding. Most stuff nowadays, they try to opt for UTF-8 encoding, try to make it universal in such a way that if I have a document and I send it over to Simon and Uchichi, but they are in two different locations, different operating systems, different machines, different systems, they should still be able to access that information without having to change anything. So what am I? And then now you'll be like, okay, sharp. Now we've thought a model. Where would this model run? There's a tool called Cloud Build. Cloud Build, now you can self-serve these models and you can be like, okay, so think of it like, I don't want to say Bazel, because eventually, sharp, you've built this tool, you think it's ready to go into production, you've stored a stamp, so you can timestamp it and you can be like, okay, this is version 2
alpha. It's ready to go, but we need to go send some data, send it to end users, let them know. And then okay, it needs to be built in such a way that it comes out as an encoding, either a torch encoding, a TF Lite, which is your TensorFlow, an Onyx, and then okay, this is where this type of model will be built and stuff. Sure. And then your artifact registry. Think of it like your Docker Hub. Now okay, this thing not only has been built and it's ready to be used, now I need to self-serve it. Now I need to put it in such a way that, okay, if Simon wants to access this model without me logging into his computer, signing in, and then physically downloading it, I can make this from a private registry to a public registry and give them that access and be like, test your heart's content. Not an issue. But then the thing that I love now is this thing called Cloud Run. Cloud Run, think of it like a Knative savvy. Now I can deploy my models serverlessly, meaning what I don't have to be awake. So it's like I don't have to be awake to do deployments. I know for a fact that okay, sharp. If the information I have right now is accurate and is efficient, and I know okay, the information has moved from the thinking mode, which is the Vertex AI workbench, it's been stored, it's been built, it's been stored now in a registry. Now I want to serverlessly deploy it and make sure it's accessible. That's going to be Cloud Run for you. And then, cool. Once that is fine, then now I need to expose it via an API gateway, meaning, okay, now I can self-serve these models and be like, guys, they're available for testing, available for usage. And then when it's like google.com, you're searching. Basically, when you're just triggering this, you're speaking to a URI, and that URI will come back to you. So if you go to your Gemini, you type in there and stuff, it's basically making a request. It's coming here to check if the model is up and running. If everything is good, it's going to come here and basically work with the information and be like, okay, what is this model capable of doing? What is it not allowed to do? I'm pretty sure you've seen there's people who've been unnecessary trying to do weird things on an LLM, and the LLM will course correct them and be like, I'm not allowed to do that, or I'm not allowed to do that because one, if it's called guardrails inside of your AI engineering stack and stuff, it's like you tell your model what it should never do, what it cannot do. And if someone comes in with that information, you mustn't block them 100%, be like, you can't do this. No. You have to guard them in such a way, OT. No, I cannot. According to this model, I cannot do that. I cannot do that. And then eventually it's just going to be like, it's fine. Let's waste each other's time. You want to be weird. You want to code C# inside of Flutter. Why? And if the model has been designed in such a way where it's not supposed to do that, it's just going to keep on pumping with you and be like, nah, I can't do that until you give up or until your battery dies. Not an issue. But then now you'll be asking yourself, okay, Alex, I can see the TensorFlow, I can see the APIs and the toolings and stuff. But what is it actually? I mean, I'm like, guys, it's very simple. You see with Google, Google is, if I'm not mistaken, okay, let me speak from my own capacity. It's one of the best lecturers, teachers of technology. So meaning that whatever I use, there will be a document, there'll be a tutorial, there'll be some form of reference that I can use and fully understand what's going on. I won't be confused and I'll be sorted. Now you'll be looking at the screen and be like, okay, Alex, so what is that? And I'm like, don't worry about it. And then we're going to be walking through what it is. This is JAX. JAX, think of it like a drop-in replacement for TensorFlow and NumPy. And someone's like, okay, NumPy. I think I've heard of NumPy. I'm like, NumPy is a numerical Python. I think that's what it stands for. And it's basically for tensor calculations, meaning that, okay, if you want to ingest data being words, video, documents, and you want to extract value from it, this is where you would leap from your normal development, writing Python, and then you move into your frameworks such as TensorFlow, JAX, and you'll be able now to write programs that extract insights. That's the first thing. You extract insights. So you're like, I want Pokemon to go and jump sharp. But then now, remember, you're not building these solutions in isolation. They're going to be used somewhere, either in a system that's massive or as a standalone like Gemini. It's going to have to be used somewhere. So meaning, okay, how do I build this? So instead of that TensorFlow image you saw, you look at this. You look at JAX. JAX has got this beautiful stack. It's called the AI stack. I'll also be sharing that with you. They have a start to end documentation telling you how to migrate from your TensorFlow, or not, yeah, TensorFlow, one, PyTorch, two, Hugging Face. They show you, hey, we know that you've been building models this way, not an issue. We're just saying that we can do it faster because JAX, the difference between JAX and TensorFlow is that with JAX, it's got this tool called JIT, just in time compilation. And someone is going to be like, hey, I'm like, okay, two steps back. I'm like, you've heard of JavaScript. Okay? Sure, you've heard of JavaScript, not a problem. You've heard of Julia, the Julia programming language. What do those two have in common? They have just-in-time compilation, meaning that instead of me trying to build something from scratch and then deploying it, so your Golang, with Golang, there's no jits, it's static. It means I have to build my program, have to run it, and I'll know then they were okay. Is this thing actually running or not? How is it performing? That's how the old ways of Python used to be done as well. You needed to build something and test it. Running it and getting information instantaneously, hey, it was a problematic approach. But now with JAX in the room, JAX has got the same capabilities as just-in-time compilation and runtime as you would have in your Julia, without sacrificing the ease of using Python. So same thing. Every time you saw NP for NumPy, you just put a J, and now it's JNP, and now you know, okay, JAX is being covered. That's not a problem. But now we're going to go into something also from Google, and something that I also prefer, because Google had two models of TensorFlow. That TensorFlow, I always call it TensorFlow Core, which means, or if I'm building Gemini, I'm building Gemini from scratch, I'm always going to be using the core TensorFlow. I am not going to sacrifice performance. I'm not going to sacrifice efficiency. I'm not going to sacrifice anything because I know that it's going to go into production. I want the best of the best. I always use core. And then they created something called TensorFlow Lite. TensorFlow Lite was targeting or directed at edge devices. Edge devices, what are those? Let's break it down. Your cell phone is an edge device. Your Raspberry Pi, edge device. If you have a home lab, and with that home lab, you have your Raspberry Pi connected, and it's connected to your lights, and it's connected to your vacuum, edge devices, because they fall underneath this umbrella called IoT, Internet of Things. Meaning, okay, cool. If I want to have Gemini running on my cell phone, I can't drop a whole core TensorFlow model in there unless I have like an Asus ROG with 28 gigabytes of RAM, 512 storage. Yeah, that's possible. I can see it happening. But if I'm using something like a Xiaomi Redmi with a 2 GB of RAM, 16 or 64 GB of storage, hey, yeah, no, you're just gonna have to format your phone because it's gonna be so inoperable. You won't be able to operate your phone because it's resource intensive running these models. But then they realized, oh no, man, what if I can say hello, take a picture, do some light stuff? And then the Google guys were like, no, let's not give them the core, let's give them the light version of it. And they'll be able to deploy. So TensorFlow Lite got renamed and rewritten. It is now called Lite RT. So the same capabilities, the same tooling, the same ways of work you've done with TensorFlow Lite. Now you have Lite RT. And the nice thing with Lite RT, it is mobile first. So they designed it from a point of like, okay, I'm expecting to run this on Android. No one's going to be confused if I run this thing on Android. Why? Because now we know that there is first class support from Google for light models to be able to run on your mobile device using Light RT. And someone's going to be like, yo, but Alex, how would I put such a machine learning tooling in there? I'm like, it's not that deep, guys. It's okay. You know why? Google created, or to even be more exact, Google DeepMind created this model called Gemma 3N, targeting laptops, targeting your edge devices, so your cell phones, tablets. They have the whole line. They're like, hey, we are ready for business. Number one, we're always ready for business. Now we just need to know where are you coming in from that line of business so that we can accommodate you. If there's resources missing out, there's toolings missing out, you reach out. I'm pretty sure whatever tool you're using or whatever forum you're using, there's a feedback. You must give feedback and be like, hey, I'm trying to do 1, 2, and 3. This is not working. Whom do I reach out to? If you want the fastest answers, go to GitHub, look for the project like your Light RT, JAX. If you can't do something, open up an issue. You open up a GitHub issue or a GitLab issue, and you put in detail what you're trying to do, the specifications of your machine, everything, and you post it there. There are moderators inside of those communities who are watching for those type of issues that come up, and you'll know, okay, I was trying to have a VO generator app on my machine using geometry in the background, but I tried putting it on my phone, and yeah, the resources, it's crying. It's not making any sense. I'm pretty sure there's gonna be someone there's like, okay, I've worked on this type of patch, I've worked on this type of component, this type of bug. Let me see what I can do, and they will work with you. And yes, even though things are still being migrated over and they're trying to get that one-to-one liking in core TensorFlow and TensorFlow Lite, we know for a fact already, okay, it's there. It's going to be what? Waiting for us to just use it. And then the demo time, let me stop sharing this one. And then let me share the big screen so you guys can see everything. Okay. And please, guys, if you guys have any questions, comments, please come through. Okay, I do see a question from Sabelo Gomere. Okay, what about fine-tuning an already pre-trained model with, oh my God, yeah. You see, the nice thing about AI and the way that AI ecosystems are currently set up, they allow you to have that flexibility. There's things called your open source the open source models. So things like your DeepSeek, I've seen MinMax, they've also opened. Who are those guys? ChatGPT. Apparently they say they did, but me, I'm sitting there, I'm like, where's the data? But I'm like, that's not a problem. And then there's Google's offerings, Gemma and Gemma 3N. those are also open models, meaning that you can go to like your Hugging Face. Hey, okay, no, it's fine. I think I'm just gonna share a tab because it's not sharing my full screen, and then we'll walk through from there. Okay, let's do this. Not you. There we go. Okay, let me know if you guys can see this tab, please. I'm gonna share again. This one, yes. Can you guys see my screen? Yes, thank you very much, Ayanda. Okay, so as you've known over the past weeks, you guys have been playing around with quick labs. So it's not only just quick labs or some labs to try out. There's this thing called, I'll take this for now, paths. If you know for a fact that, okay, I love data, but I don't want to do too much of the dev work. And it's like, okay, you might fall underneath your data analytics type of track and stuff. You come over here and you look for that path that you would like to be. I always tell people, I'm like, learn the latest things in technology. So generative AI is the latest offering, or in terms of certification, operations. These other ones have always been there. Always learn the latest thing, so that by the time when it becomes a standard, you are so far ahead and so knowledgeable about the tooling, about the framework, about the entire stack, that you are not worried when they bring that type of business to your front door. And you would see security operations, those going for the Google security certifications, hybrid cloud, very, very important when you're not only architecting for GCP, but other clouds that needs to communicate to GCP. So AWS, Huawei Cloud, Alibaba Cloud, Tencent Cloud, Azure, name the cloud. If it has an offering to be, I don't want to say webhooked, but basically to connect into it and fetch information, this is where you would mostly be diving deep into. And as you see, zero practice. We spoke about this with the introduction to Kubernetes with role-based attribute controls, security, again, site reliability, one of the most important. If you understand the workflow from start to end, it's going to be very beneficial. Gemini, government, cloud computing foundations, certificates. You see, even I'm learning new things to show that the industry is never set in stone. Things are always changing. Information is always changing. The ways we work is always changing. You being at the forefront and showing that you understand what it takes and you can bring what is required for business is always going to put you in a different WhatsApp group than the other participants that's also in the same group as you, who are not pushing as much or as expected from business. So I'm just going to go one back, and you would see how thorough, because someone's like, I want to study AI. I'm like, if you want to study AI, study machine learning, because machine learning has always been there. I'll even say 10 years, 10 years minimum. So 2015, they have been the masters of machine learning. They have been pre-baking this machine learning into production, into all the toolings. It's best to learn it from the industry's best. They have a machine learning engineer learning path where they break down with 21 activities. And someone's gonna be like, after tonight I'll be machine. And I'm like, you can fly through these courses, yes, but do you understand? Do you understand not only the workings, but also the edge cases that come up with you putting those solutions in? So as you would see, this is the guide, and I'm like, how are you looking at the guide if you don't know what machine learning is? I mean, you can get an overview of what's going on, but I'm like, leave that for last. As you would see, it's classified underneath advanced. No, someone was like, what's the best way to fly? It is like, you start by crawling, then you stand up. You master stand up. After you master stand up, you start walking. After you start working, then you might start running. But that's the thing, it's in stages. You need to learn these things. The toolings that I've shown you, the APIs I've shown you, those are just the high level view. If you want to go deeper, I'm pretty sure you guys are familiar with the T-shaped model. You can have a breath. Let me not mess it up. T-shape model. Yes. With an image and share this. There we go. Broad, deep, meaning that you can learn everything. You know, people are just distro hopping or learning everything, but they never go deep into it to become subject matter experts in that particular tool. This is where we would measure them. It's like, how bored are you? Do you understand the touching points, the failing points of the system, the working points, observability points? Do you know where the network sits? Do you know what the system is actually trying to achieve and do? But boom, it's failing on the network side. How deep of network knowledge do you have? That's why when I'm showing you this, I'm like, guys, it's okay. You can look at this, get an overview of what you're working towards, but always go through the introductory courses. Those are your basics. Never skip your basics, because your basics will become your foundation that's eventually going to build up on to the future that you are trying to aim for. So you would see there's a tour for hands-on. Pretty sure you guys have gone through that, but this is where it starts cooking, Introduction to AI and machine learning on Google Cloud. So on Thursday, we're basically going to be going over this. We're going to be trying out some labs to try and give you that feel of what it means to do AI and machine learning on GCP. Then you'd see prepare data for ML APIs for Mr. Sabelo. If you have that data and you know exactly what you're looking for, using Google free tier or GCP free tier, you can start measuring and seeing like, okay, what can I actually do with current offerings? And there's a lot. There's a lot of offerings. We'll try and squeeze that in because I can see 7 o'clock is approaching. Working with notebooks in Vertex AI. I was doing a lab on that with your agents to agents. And then the one that sold me and officially made GCP the only provider that I respect and I love and I learn, BigQuery. You see BigQuery, guys. Back then, 2019, we were doing this lab, and for me, SQL has always been slow, so I never took it to heart already. It can be a thing that I will be working with on a daily. And then I went through a spreadsheet with 1 billion rows. It took me 16 seconds to go through 1 billion rows. And at the time, I was like, how? Because if you're putting 256 gigabytes of RAM, that's interesting. That's maybe. 512, you're pushing it. And then one of my lecturers was like, no. They have 1 petabyte of RAM behind BigQuery. And I was like, that amount of power just to go through data that's structured, so much possibilities can be achieved. And tell me right now, which SQL offering
What about fine tuning an already trained model with my data? I'm pretty sure that is possible on Google Cloud. I will find you the exact service that does that and how to actually do that. In the meantime, do you have any more questions regarding this topic? Just to add, guys, you can find this on our YouTube channel. Go to GDG Soweto on YouTube and then just search for the Cloud to ML Architect Bootcamp. We already have a few sessions there, and this session will be dropped just before Wednesday. Just before Thursday's session. Oh, guys, I've actually been informed, Sabelo, so you can actually use Vertex AI for fine tuning your already trained model. So just check out Vertex AI. I think that actually, come to think of it, that will be our third session in the phase 2 of our bootcamp. So that's where you'll learn about that. Okay, guys, 2 more minutes. Do we have any more questions before we wrap up? Okay, guys. Um, thank you so much for joining us tonight. Let's see you again on Thursday, same time, 6 p.m. Have a great Tuesday, guys. Bye, everyone.